Hello students, myself Mehul from LJIET Institute of Engineering and Technology. So in last session we solved one numerical based on geometric transformation, and in that numerical we scale one triangle about some particular points. So in today's session we have to solve one more numerical based on rotational geometric transformation. Okay, so in today's session we have to solve numerical based on homogeneous transformation matrix for the rotation. Okay. So this is the example number 1. A rectangle ABCD has vertices A1, 1, B2, 1, C2, 3 and D1, 3. We have one rectangle and 4 points of the rectangle. It has to be rotated by 30-degree counterclockwise. Now we have to rotate this rectangle in anti-clockwise direction about particular point P3, 2. Clear? We have to rotate this rectangle about point P, and we have to rotate this rectangle 30 degree in anti-clockwise direction. Determine the new coordinate of the vertices of the rectangle. Clear? The original rectangle coordinate is given. We have to move this rectangle in 30 degree anti-clockwise direction about point P, and we have to find rotational rectangle coordinates. Clear? So our data is given rotation about point 45 degree counterclockwise direction, that's why theta is equal to 45 degree. Rotation about point P3, 2. So first translate the object. Now you all know, we already discussed this theory. If we have to move any of the object about particular point, at that time we have to first shift that point to the origin. After that we have to perform the geometric transformation operation, and again we have to shift that point to its actual position. Okay, so first translation, second rotation, and again inverse translation. So in this numerical we have to follow these three processes. Okay, now in this numerical we have to shift point P to origin. Now coordinates of point P, that is 3, 2. Clear? So if we have to move this point to origin, so we have to translate this point minus 3 unit in x axis and minus 2 unit in y axis. Clear? Because coordinates of point P, that is 3, 2. Okay. So this is the numerical A dash, B dash, C dash and D dash. That is the new coordinates of the rotational rectangle. ABCD, that is the actual rectangle. Now three process we have to follow. First, translation. Translation means we have to move point P to the origin, because we have to rotate this rectangle about point P. And as you all know, what is the equation of the translation? Clear? Translation means we have to move any of the object from one place to another place. And we already derived equation for the homogeneous transformation matrix for the translation. That is 1, 0, 0. 0, 1, 0, tx, ty, 1. Tx and ty indicate translation in x axis, ty indicate translation in y axis. Clear? So we have to move point 3, 2 to its origin point. That means we have to move minus 3 unit in x axis, means value of tx, that is minus 3, and value of ty, that is minus 2. So that is the translation process. Second is rotation. Now rotation, we have to rotate this rectangle in counterclockwise direction 30 degree. We already derived equation of the counterclockwise direction for the rotation, that is cos theta sin theta 0 minus sin theta cos theta 0, 0, 0, 1. Value of theta, that is 30 degree. So we have to put this equation over here, and in this equation we have to put the value of theta. So matrix for the rotation, that is cos 30 sin 30 0 minus sin 30 cos 30 0, 0, 0, 1. And last, that is inverse translation. In inverse translation we have to translate point P, coordinate of point P, that is 3, 2. First we shift this point to origin. Now we have to again shift this point origin to its actual position. Means we have to give translation 3 unit in x axis and 2 unit in y axis. Clear? And we have an equation of the translation, that is 1, 0, 0, 0, 1, 0, tx, ty, 1. So instead of tx, ty, we have to put 3 and 2. So last matrix, that is 1, 0, 0, 0, 1, 0, 3, 2 and 1. This step is the most important step for any of the numerical, because after that we have to just do the matrix multiplication. Clear? So this is the main step of this numerical. First you have to write down coordinates of the rectangle. So we are here for in first step, first we write down all the coordinates 1 1 2 1 2 3 and 1 3. Clear? Or z coordinate of all the points we have to consider as a 1. Clear? Second, that is translation. So translation matrix, we have to move first point P to the origin. That's why this is the translation matrix 1 0 0 0 1 0 minus 3 minus 2 1. Second, third step, that is rotational matrix, and last inverse translation. As you all know how to multiply two matrices, clear, and we have to start multiplication from the backward direction, clear. So in next step, step number 2, you have to write down first two matrices as it is, clear, and you have to multiply last two matrices. Before that, you have to put the value of cos 30 and sin 30 in the matrix. That's why in next step, first matrix as it is for the rectangle coordinates like 1 1 1 1, 2 1 1, 2 3 1 and 1 3 1. Second, 1 0 0 0 1 0 minus 3 minus 2 and 1. Second, that is rotational matrix. Put the value of cos 30 is equal to 0.866 and sin 30 is equal to 0.5. Put that value over here. So 0.866, 0.50 minus 0.5, 0.866, 0 0 0 1. And last matrix you have to write as it is. Clear? Now we have a total 4 matrices. Clear? And once you start to solve numerical, in each step we have to reduce one matrix. Like so total 4 matrices. In next step convert into 3 matrices. In next step converted into 2 matrices. And last we will find the answer in 1 matrix. That is the new coordinate of the rotational rectangle. Clear? So we have 4 matrices. So write down first 2 matrices as it is and multiply last 2 matrices. And now you all know how to multiply 2 matrices. Clear? First row, first column, first row, second column, first row, third column. Same way you have to repeat the procedure for the second row. Second row, first column, second row, second column, second row, third column. And again you have to repeat same procedure for the third row. Third row, first column, third row, second column, and third row, third column. You have to multiply all the row and column like this. Clear? So write down first 2 matrices as it is like 1 1 1, 2 1 1, 2 3 1 and 1 3 1. Next translation matrix, write down as it is 1 0 0 0 1 0 minus 3 minus 2 and 1. And multiplication of last 2 matrices like 0.866 into 1 plus 0.5 into 0 plus 0 into 3. This is the matrix multiplication of first row of first matrix and first column of second matrix, and answer is 0.866. Now you have to repeat this procedure, first row of first matrix, second column of second matrix. So you have to multiply 0.866 into 0 plus 0.5 into 1 plus 0 into 2. So answer is 0.5. So right answer over here 0.5. Same way, first row of first column and third column of second matrix. Clear? So 0.866 into 0 plus 0.5 into 0 plus 0 into 1, and answer is 0. So this is the we find the answer for the first row. Now you have to repeat same procedure for the second row of first matrix, and you have to multiply second row with each column of second matrix, and you will get answer of the second row, that is minus 0.5, 0.866 and 0. Same way you have to repeat this procedure for the third row of first matrix, and you have to multiply third row with each column of second matrix, and you will get the final answer is 3, 2 and 1. Clear? So in next step we have, in second step we have 4 matrices. In next step now we have 3 matrices. Now again you have to repeat same procedure. First matrix write down as it is, and you have to multiply last 2 matrices. Clear? So write down first matrix as it is and last 2 matrix. If you multiply, then these 3 matrices converted into 2 matrices like this. A dash, B dash, C dash, D dash. Write down first first matrix as it is 1 1 1, 2 1 1, 2 3 1 and 1 3 1. And if you multiply last 2 matrices, clear, and you will get, and you have, now you all know how to multiply 2 matrices. Clear? How to multiply 2 3 cross 3 matrix. You all know you have to consider first matrix as a left hand side matrix consider as a first matrix, and right hand side matrix consider as a second matrix, and you have to multiply these two matrices, and you will get the answer of this multiplication of that two matrices, that is 0.866, 0.50, minus 0.5, 0.8660, 1.402, minus 1.232, and 1. Clear? Now that three matrices converted into two matrices. Now you have to multiply these two matrices and you will get your final answer of a rotational rectangle about point P. Okay, so if you multiply these two matrices, like first row of first matrix, first column of second matrix, so 1 into 0.866 plus 1 into minus 0.5 plus 1 into 1.402, and you will get answer is 1.768. You have to repeat same procedure for the first row and second column multiplication, and you will get 0.134, and first row third column multiplication, and you will get answer is 1. You have to repeat same procedure for the second row, third row, and fourth row. Okay, and the final answer of that is 1.768, 0.134, and 1. That is the answer of the point A. A point moved to the A dash, and the coordinate of A dash, that is 1.768, 0.134. Coordinates of B dash, that is 2.634 and 0.634. Points of C dash, that is 1.634 and 2.366, and point D, that is 0.768 and 1.866. This is the answer of the new coordinate of after the rotation of the rectangle about point P. Now you have to show this all the procedure in one graph. In that graph you have to draw actual rectangle and rotational rectangle. Clear? And you can easily understand how to rotate a rectangle about any of the point. Clear? So answer that is already we derived. Now you have to draw actual rectangle and a rotational rectangle. Now actual rectangle, that is ABCD. Clear? So in this figure you can easily understand A point, the coordinate of A, that is 1, 1. B point 2, 1. C point 2, 3, and D point 1, 3. So you have to draw one actual rectangle. Point P, that is 3, 2. So you have to plot point P in the graph, and about point P we move this rectangle 30 degree in anti-clockwise direction. Clear? So you have to plot a rotational rectangle coordinates over here. A dash. So put A dash over here. Approximate B dash, C dash, and D dash. If you plot A dash, B dash, C dash, and D dash, and join all the line, at that time generate A dash, B dash, C dash, and D dash. That rectangle will be generated. So this rectangle, from the figure you can easily understand that ABCD rectangle move 30 degree in anti-clockwise direction about point P. So that rectangle is rotated anti-clockwise 30 degree about point P, and that is easily understand from this figure. Clear? So this is the numerical based on geometric transformation. And in geometric transformation, this numerical is based on the rotational, anti-clockwise rotation. In previous lecture, we saw numerical based on the scaling. In this lecture, we saw numerical based on the rotation. Clear? So in next session, we will discuss some new method to solve numerical of geometric transformation. Thank you.